are mainly two phenomena which are being used by the researchers in the research community, which are based on the quantum principles. One is superposition, and another one is actually entanglement. While using these two principles, you can think of them as two different paradigms. For example, for the superposition, you are just trying to encode your particular states into the quantum states which are represented by the qubits, right? For example, you might want to solve a particular brute force problem, like say traveling salesman problem. So you might think of it as possibly encoding each of the possible path into one quantum state with a probabilistic sampling, and try to find out or try to increase the amplitude of the best path at the end of the particular algorithm run, right? So this is how you can actually think of formulating your problem statements. And now talking of about entanglement, how it can be used in the quantum computation is that you can actually try connecting two particular qubits, because what entanglement says is that if two qubits are entangled, then the outcome of one particular qubit will be actually possibly dependent on the other qubit, irrespective of the distance between them. So what will happen is that if you just entangle those particular two qubits, then the result of one qubit will influence the result of other qubit, right? And you can use it for your benefit, right? Multiple of the researchers are using this particular phenomenon for, say, entangling the particular qubits of the neural networks, so that the neuron can be actually fired based on the activation of the other neuron. That's how the researchers are actually using. That's one possible example of using entanglement. And rest you can use if you actually are able to find something new to entangle and to actually show the potential benefit. Then that's actually a research paper.